This problem was about creating your own parametric path that's linear, but it's a motion that might be less familiar along a linear path. So we want it to start at a particular point, move to another one, and then return to the original point sometime later. So I request that you don't use piecewise defined functions, but you can use any other type you want. I really like it when students reveal their thought process to me. So this student clearly was thinking out some possibilities. They thought, okay, like here's x as a function of time. We want it to start at -3, go up to 3, and then back again as we go from 0 seconds to 5 seconds to 10 seconds. So they thought, look, it could be absolute value, straight. It could be an upside down parabola, or it could be a sine or a cosine function. And I agree all three of those could work. They opted to use absolute value because they thought it would be simplest to solve for. So let's imagine two different versions of what the x of t function could look like. Here, I just wrote down the information from the problem as a graph. So at time 0, x coordinate starts at -3. At time 5, it goes up to +3. And then at time 10, we go back to -3. Same information here, except I connected it with an upside down parabola. Okay, so for both of these, I think it's best, so like let's imagine a family. So the family in this case would be a t squared kind of a family. The family in this case would be absolute value t. But in both cases, we have to translate it right, translate it up, flip it upside down, and then scale it. So let's just look at the translations and the flipping. So here I would have on the inside, shifting it right by 5. On the outside, shifting it up by 3. And then on the outside, I'm going to flip it with a negative sign, but then I'll need some scale factor that will scale it to go through the exact points I want. Let's do the same thing on this side. So on this side, I could have shift it right by 5, shift it up by 3, but then I'll have to solve for some kind of scale factor. So let's go ahead and solve for the scale factor. I'm going to plug in the values at this point. So this is 0, -3. So the 0 is time, that's the horizontal axis. The -3 is x, that's the vertical axis. So here I'll have -3 equals -k, absolute value 0 minus 5 plus 3. So this is, so on the inside of the absolute value, I've got -5. Absolute value makes it +5. So now it looks like this. So the +5 I just moved over here to the other side of the k. Now we can go ahead and solve for k the rest of the way. I'll subtract 3 and I'll divide by -5, giving me k is 6/5. And so now I can write the final equation again. If I can squeak it on the screen here. X equals, I'm copying from up here, so negative, and then my k value is 6/5. So -6/5, absolute value t minus 5 plus 3. Let's do the same thing on this side. So again, I'm going to substitute some values. -3 for x. When I plug in 0 for t, that will give me -5 squared, which becomes +25 because I'm squaring it. So same thing, let's solve. I'll subtract 3, so that gives me -6. Then I'll divide by the 25. Gives k equals -6/25. So if I rewrite the equation, I've got, let's see. Oh, how did I end up with a negative sign here? Hold on. Well, here, let me say out loud what I'm noticing. What I'm noticing is my k value I wrote down here was negative. But then if I'm going to plug that up here, I'll have opposite a negative. So that becomes positive. But I know that can't possibly make sense because my parabola is upside down. So that's why I'm pausing and going back to look. And here's the problem. So I subtract, -3 subtract another 3 is -6. I said divide through by 25, but remember the negative sign is still in front of the k here. That didn't go anywhere. So then if I have -k equals negative this thing, that's the same thing as k equals 6/25. You could multiply both sides by -1, for example. Okay, so now plugging in 6/25 back for the k, that gives me opposite 6/25, t minus 5 squared plus 3. So you can see the equations are very similar. In both cases, we have sort of the vertex, if you want to call it that, at the same location. That's why we have the -5 and the +3. You can see that the function is different, squared versus absolute value. And you can see that the scale factors are different but related. The reason they're related is because the 5 got squared here because we had a t² function, whereas in this case, the 5 just remains 5 because we had the absolute value. Okay, well, so that's how we're going to get, hold on. So that's how we're going to get the x of t equations. What about the y of t equations? So if you wanted to, you could go through the same process again with y. You'd have here's time, here's the y value. You'd decide where the y coordinates were and draw your parabola and solve for it. A different thing you could do is, back in the original problem, it actually said the path that we wanted it to follow, the linear path. It was y equals 2x plus 1, I think. So as long as you've got this, it's easiest to just substitute directly in there. So that would give us y of t is 2 times this entire x of t equation. So actually, well, I guess, all right, fine. We'll write it all out. 25t minus 5 squared plus 3. And then plus 1 on the outside. And then if you're going to simplify that, 2 times 6 is -12/25. 2 times 3 is 6. T minus 5 squared. So 2 times 3 is 6 plus 1 is 7. So there you go. You could do an analogous thing on the other side.